Okay, we are working with volume today, and we kind of talked about this last time, just a little bit, but we have a base picture. There's always going to be what we call a base area of our figure. And for this one specifically, we are going to look at a figure we already know. It's this right here. And whether or not you know if it's a square or a rectangle, I highly suggest always just use a rectangle. Can't go wrong with a rectangle. So when we do this, what we want is we want to do length times width. That's what we did all day yesterday. Gentlemen? Okay. So we are going to do length times width. We talked about this yesterday. It does not matter 2 times 3, 3 times 2. It doesn't matter either way. We're going to get the same answer. So I'm going to make the length 14 and the width 17. So I'm going to plug in 14 and 17 in for our length and our width. And when I do that, I have no idea what it is. 14 times 17, right? Is that right? Yeah. 238. So you should get 238 as your area for this right here. And all we're doing is finding the area of the base shape. So we call that the base area. Now what we are going to do is we are going to multiply it by the 3-dimensional height to find the volume. Once again, we have a 2D shape. A rectangle is just 2 dimensions. It's a length and a width. We can draw that on a sheet of paper. Once we start doing a 3rd dimension, we have to put some perspective on it. It's called perspective drawing. You have to put a little angle on it so that you can get the 3rd dimension. If you have a rectangle on a regular 2D surface, you wouldn't see diagonals. You would just see straight lines. So that's why they put the right angles in the corner, to make sure that you understand that if I were to look at it in a 2D space, this is the shape I would be looking at. One of these would be 14, the other would be 17. That's our base shape. Now, what we're going to do to that base shape is we're going to times it by what we call the 3-dimensional height. I'm going to change this color. Let's go with pink. That didn't change much. We need a 3-dimensional height on this, which we call 19. Now, if you are looking for the volume is the base area times the height. So my volume is going to be my base area of 238, and I'm going to multiply it by my 3-dimensional height, which is 19. So I'll take that 238 I got before, times it by 19, and I should get 4,522. So my volume is going to equal 4,522. And centimeters cubed. Now that we have a 3rd dimension, it's going to be cubic units. Because we have a length, a width, and now we have a height. So we have 3 different units of measure we're multiplying together. That's why you get units cubed. And once you do that, that will tell you if I had a container that was 14 centimeters by 17 centimeters on its base, and then it was 19 centimeters tall, it can hold that amount of liquid. So we do a conversion to put it into gallons or liters or whatever you wanted to do. But this is how you would get that unit of measure. Questions? How does that feel? Does it feel okay? And while you're using mine, it will charge over. Sorry. Did not see that. Okay, let's go on to the next figure. Now, all those rectangles are going to be the same. What starts to get tricky is when we change the shape. So let's look at this. This is number 5. We're looking at the triangle. And what you have to see is this base triangle right here. And then our 3-dimensional height is right here. That's our 3-dimensional height. But we only want to focus on our base shape right now, the triangle. And if you look at your formula sheet from yesterday, we do base times height divided by 2. Now understand, the triangle height and the 3-dimensional height are 2 different h's. Can't stress that enough. We know the 3-dimensional height already. We can already establish that. That is 4. So whether you talk about a piece of pie, a piece of cake, a piece of pizza, whatever you want to talk about, the bottom crust, there is a height to that for a triangle. And then the actual thickness of it is a different height. That's your 3-dimensional height. So the thickness of it is your 3-dimensional height. So when we look at this triangle, I'm going to call this base. I'm going to call that height. You can flip-flop them, one versus the other. The only thing you want to pay attention to is making sure that when you focus on a height, it has this box in the corner. And you'll be like, well, it's always got that box. Well, but look at this one. This I would establish as my height in this problem. So when I'm looking at this triangle, when I say this triangle, I'm talking about the bottom piece of cheese or the crust of whatever you're talking about. That bottom triangle, this right here, is my height of the triangle. That's 3.7. And apparently it's in miles. And then when I talk about my 3-dimensional height, that would be the 10 that's there. Okay, so let's go back to this one. So this height is going to be 12, and then the base is going to be 9. So I'm going to plug those numbers in. So I'm going to do 12 times 9 and then cut it in half. So I'm just going to do 12 divided by 2 is 6 times 9. That should give me 54. So my base area for my triangle should be 54. Now establish a volume, which is the base area times the height. So my volume is going to be 54. And then I'm going to times it by 4. Because that's my 3 dimensions, my 3-dimensional height. And so 54 times 4 should give me 216. And then meters cubed, so units cubed. Go ahead.
For number 8, since you go to number 8.
Yeah, let me pull that up real quick. Okay, number.
Does it matter which way the box is pointing? Or is it just the number, like it's always going to be the number on the inside of the box is the height?
So that's a good question.
Or is it just the way that the box points?
The box.
Because it's pointing at the 13, it's on the side of the 13, not the 9.6.
Right, so we want to make sure.
Or is it just always going to be the number on the inside? Does it not matter?
When I look at this, and we're dealing with what they call prisms, okay? In order for this to be my base shape, it's got to come back and make another rectangle back here for it to be a prism. And so we definitely want this to be our height, our three-dimensional height. And I don't think that was your question, but I want to say that for anybody watching this. This is our three-dimensional height, and I'm going to label it in pink like I've done all the other times. But our base shape, we're going to focus on this triangle down here.
The number on the inside, it doesn't matter which way the box is pointing.
No. And then this, because it's at the 90 degrees, this is the height of our triangle. So the height of the triangle is 9.6. The three-dimensional height is 13. Did I clear that question up for you, Allison?
Yeah, I think so.
Okay. So then if we were to do this, base times height divided by 2, I would do 9.6 times 18, cut it in half. And then the volume would be that area times it by 13. All right. When we talk about perimeter, in a circle, it's called circumference. For some reason, circle wants to be special. When we talk about a volume of a circle, because what is this title? Isn't it titled Prisms? When we talk about prisms, we talk about the base shape. And the base shape is a rectangle. So we have a rectangular prism. The base shape's a triangle. We call it a triangle prism. And of course, when it comes to a circle, you can't call it a circle prism. Circles just like to do that. So when we talk about a circular prism, what we are talking about is a cylinder. So that's where that name comes from. And I always want you in your brain to say soup can. You should always be thinking of a soup can when you think of a cylinder. Think about the top of the soup can, the bottom of the soup can, and then there's a height associated with how big your soup can is. Now, for our area of a circle, it's not changing. It's pi r squared. R being the radius, and the radius being from the center of the circle out to one of the sides. Now, this is not what this says. What did they give us in our circle? The diameter. It goes all the way across. So if it goes all the way across, what do we need to do? Cut it in half. And then that gives us a radius of 2. So from the center out is just going to be a 2. So then we're going to plug our 2 in. So we're going to do pi times 2 squared. So I'm going to do pi times 2 squared and get 12.57. So this is the base area of my circle. So my base area of my circle is my BA. Then we have a three-dimensional height again. This three-dimensional height plays a big picture, plays a big role in volume. So that three-dimensional height is going to be 9. So our volume equals base area times the height. The base area is going to be 12.57. And my height is going to be 9. And we're going to get 113.13. So my volume's going to be 113 point, was it 13, right? Yep. And we're going to call it miles cubed. Yes, no, maybe so. How do you feel? Is that okay, not okay? And remember, we're doing the base area, and it should match the top and bottom. If we look at our triangle, base area should match the bottom with the top. Same thing here and here. It's easier to see if they're completely separated. But you see that shape on the top and bottom. You see that rectangle on the top and bottom. And with a cylinder, you definitely can see it because it's the only shape you really can identify in a cylinder because it's rounded all the way around. All right. So then if you are given the diameter, we need to cut that in half. And focus your attention on your three-dimensional height being here. So your three-dimensional height is, they flipped the soup can on its side. And that's what the issue is for this problem. So we're still going to do pi r squared. We're going to put our radius in here. Remember, our radius is from the center just out to the side. So that's just going to be 13, which is 169 pi. And that's 530.93. 530.93. And your three-dimensional height is sideways. It's on its side, is 10. Volume equals base area times height. Plug in your base area. Our base area is our circle, which is 530.93. And then we're going to multiply it by our height 10. Okay, last one. Let's look at the story problems real quick. This is number 15. So number 15, we have the volume of a rectangular box. So we know we have a rectangle. Our base area is length times width. It is literally giving us the volume. It told us what the volume is. The volume is 560. And then it gives us the three-dimensional height of 5 meters. One of the dimensions of my base area, one of the dimensions of the base is 16. So I'm going to plug 16 in for my length. and leave the width as W. Now, we know volume equals base area times the three-dimensional height. Our volume is 560. Our base area, go back here, is 16W. Times it by our three-dimensional height, which is 5. And now you can just solve for the variable. So 560, if I did 5 times 16, I would get 80W. Divide both sides by 80, and you'll find what that W is. And it's in meters. Any story problem, you should have a units established with it. And you should get 7 meters for your solution. Yes, no, maybe so. All right, so in the classroom, first off, we are looking at 8.2 volumes of prisms. We are in 9F3, and you have to get a 70 on your IXL. And anything you need, the Canva's in here, homework, all that good stuff.